The binomial distribution. Before anything else, I have here the learning objectives. First, find the exact probability for X successes in N trials of a binomial experiment. Second, find the mean, variance, and standard deviation for the variable of a binomial distribution. Historical note. In 1653, Blaise Pascal created a triangle of numbers called Pascal's triangle that can be used in a binomial distribution. Let's proceed to the binomial distribution. The outcomes of the binomial experiment and the corresponding probabilities of these outcomes are called a binomial distribution. It also summarizes the number of trials or observations when each trial has the same probability of attaining one particular value. The binomial distribution with parameters n and p is the discrete probability distribution of the number of successes in a sequence of n independent experiments, each asking a yes or no question, and each with its own Boolean valued outcomes, success or failure. Let's tackle what is binomial experiment. A binomial experiment is a probability experiment that satisfies the following four requirements. First, there must be a fixed number of trials. Second, each trial can have only two outcomes or outcomes that can be reduced to two outcomes. The outcomes are usually classified as successes or failures. For example, the correct answer to a multiple choice item can be classified as a success, but any of the other choices would be incorrect and hence classified as a failure. Third, the outcomes of each trial must be independent of one another. And lastly, the probability of a success must remain the same for each trial. Many types of probability problems have only two outcomes or can be reduced to two outcomes. For example, when a coin is tossed, it can land heads or tails. When a baby is born, it can be either male or female. In a basketball game, a team either win or lose. A true or false item can be answered in only two ways, true or false. Other situations can be reduced to two outcomes. For example, a medical treatment can be classified as effective or ineffective depending on the results. A person can be classified as having normal or abnormal blood pressure depending on the measure of the blood pressure gauge. A multiple choice question, even though there are 4 or 5 answer choices, can be classified as correct or incorrect. Situations like this are called binomial experiment. Here are some notation for the binomial distribution. P of S is the symbol for the probability of success. P of F is the symbol for the probability of failure. P is the numerical probability of a success. Q is the numerical probability of a failure. P of S is equal P, and P of F is equal 1 minus P is equals Q. N is the number of trials. X is the number of successes in N trials. Note that X is greater than or equal to 0 but less than or equal to N, and X is equal to 0, 1, 2, 3, and so on. The probability of a success in a binomial experiment can be computed with this formula. Binomial probability formula. In a binomial experiment, the probability of exactly X successes in N trials is P of X is equals to N factorial over N minus X factorial times X factorial times P to the power of X times Q to the power of N minus X. I have here some examples. A survey found that 1 out of 5 Americans say he or she has visited a doctor in any given month. If 10 people are selected at random, find the probability that exactly 3 will have visited a doctor last month. In this case, n is equals to 10, x is equals to 3, p is equals to 1/5, and q is equals to 4/5. So, na 4/5 ni siya kay nakamantay 5 ka Americans nga ni-visit sa hospitals, niya -1 nga ni-visit. So, we have to substitute each value. So, it will become p of 3 is equals to 10 factorial over 10 minus 3 factorial times x factorial times 1/5 cubed times 4/5 to the power of 7 minus 3. And the final answer is 0.201. Another example, a survey from Teenage Research Unlimited from Northbrook, Illinois, found that 30% of teenage consumers receive their spending money from part-time jobs. If 5 teenagers are selected at random, to find the probability that at least 3 have part-time jobs, it is necessary to find the individual probabilities for 3 or 4 or 5, and then add them to get the total probability. First, we get is the value of p of 3. So, p of 3 is equals to 5 factorial over 5 minus 3 factorial times 3 factorial times 0.3 cubed times 0.7 to the power of 5 minus 3 equals to 0.132. So, maong ang q is 70% kay naan may 30% of teenage consumers receive their spending money from part-time jobs. So 100 minus 30% is equals to 70%. Next, p of 4 is equals to 5 factorial over 5 minus 4 factorial times 4 factorial times 0.3 to the power of 4 times 0.7 to the power of 5 minus 4 is equals to 0.028. Next, p of 5 is equals to 5 factorial over 5 minus 5 factorial times 5 factorial times 0.3 to the power of 5 times 0.7 to the power of 5 minus 5 equals to 0.002. Hence, p of at least 3 teenagers have part-time jobs equals 0.132 plus 0.028 plus 0.002 equals 0.162. So, there is 0.162 probabilities that at least 3 of them will have part-time jobs. We proceed to the mean, variance, and standard deviation for the binomial distribution. The mean, variance, and standard deviation of a variable that has the binomial distribution can be found by using the following formulas. Mean is equals to n times p. Variance is equals to n times p times q. And standard deviation is equals to square root of n times p times q. These formulas are algebraically equivalent to the formulas to the mean, variance, and standard deviation of the variables for probability distributions. But because they are for variables of the binomial distribution, they have been simplified by using algebra. For example, a die is rolled 480 times. Find the mean, variance, and standard deviation of the number of 3s that will be rolled. This is a binomial experiment since getting a 3 is a success and not getting a 3 is considered a failure. Hence, n is equals to 480, p is equals to 16, and q is equals to 56. Let's substitute each values. So mean is equals to 480 times 16, the answer is 80. Next, variance is equals to 480 times 16 times 56, the answer is 66.67. Next, standard deviation is equals to square root of 480 times 1/6 times 5/6, the answer is 8.16. Let's have another example. The statistical bulletin published by Metropolitan Life Insurance Corporate reported that 2% of all American births result in twins. If a random sample of 8,000 birds is taken, find the mean, variance, and standard deviation of the number of birds that would result in twins. Again, just substitute each values. Mean is equals to 8,000 times 0.02. The answer is 160. Next, variance is equals to 8,000 times 0.02 times 0.98. The answer is 156.8. And standard deviation is equals to square root of 8,000 times 0.02 times 0.98. The answer is 12.5. For the sample, the average number of birds that would result in twins is 160, and the variance is 156.8 or 157, and the standard deviation is 12.5 or 13 if rounded. That's it for the binomial distribution. I hope you have learned from what I have discussed. Let us now move on to the next reporter.